Oh, and by the way, since I had a few difficulties figuring out how to solve this level again, I already told you about this. There's this website which is called Geeks for Geeks, and yeah, the component that we were building is basically a magnitude comparator. And yeah, what does it do? It does basically exactly as we can see here. Or not exactly. Because this one can actually no, it basically it just gives another output, right? It gives a true for when A is less than B on the last line, whilst giving a true on the first line when A is greater than B. And it also has a line that determines whether they are equal. This is a 1-bit magnitude, n-bit magnitude, n-bit comparator. We can have a look at this. And we can, as I already told you in previous levels, we can identify. You can see this is a XNOR, right? Where's the XNOR? There it is. Judging by this dot in the front and the curved double-lined back, looks basically exactly like this component, right? And we can actually use this website to, okay, how does this work? If it is not A, and this is an AND, right? And it's B, B is greater, yes, of course. If they're equal, right? XNOR. We get the equality. And in case of it's not B but A, we then know that A is the greater one. So this is 1-bit. We can have a look at this website, and actually gives us can be a very valuable resource, in my opinion. Not only this website, if you know how the component is called, like, you can look up a schematic sometimes. 2-bit magnitude comparator. It actually gives the solutions for equality. Greater and less. Yes, this makes sense as well. It's basically, no, it's different. 4-bit magnitude comparator is where it gets in where it gets interesting. Look, this is basically exactly what we've built. Now it's a little bit different. Let's have a look at this. This is cascading. You can see that. So this is an, what is this? It's using a NOR gate, right? This is a NOR. When it checks, if there's, using AND gates, the difference in these two. Oh, it's built this way because we will determine three different. Oh, this is interesting. What is this? No, this is just an OR. Oh, and by the way, we can theoretically like we have a three-way OR, right? We could theoretically build a component that is, I don't know, what is this, 1 2 3 4. We could build a four-way OR instead of going like this, using a custom component. The four-way OR. Well, this is the highest, right? A3 is the most significant. Yes, it has to be. So B, yes. If B is true, A is not true, then B is greater than A. This is the most significant. So in which case, if either one of these are true, right? They would be... Right. You are a NOR. Okay, if wait. So this is a NOR. Yes. If both of these are false, that is the only way this would give a true. And yes, makes sense, because only if there's a difference in these two, one of these would light up. So if there's, if both are true, none of these AND gates would activate. So we would then still be able to use the NOR gate. And this is true for all these NOR gates which determine equality. And they all have to light up. Because this way we can determine if they are equal. Now, using this OR means there's no difference in the highest bit, the most significant bit. So if this is the case, and then the next highest, becomes relevant. And if it is B, if B is the one that is lighting up, then B is higher. And then in case it's A, then we have an OR that decides that A is higher than B. Yes, and this way you can use these just as you can use mine, right? From the levels that I've showed you, from the solutions that I've gave you to the levels that I showed you while playing the game. You would be able to build your own circuits. Just try to understand the logic, at least. Well, I feel like this is my recommendation. I mean, in the end, this is only relevant if you plan on, like, if you want to understand this stuff. I guess this will be my recommendation. And this stuff here, at the point we hit 4 bits, we can chain this infinitely. It just becomes way more complex. I actually prefer my solution because it has this cascading and which this one doesn't. It does, but it basically takes a million inputs to use this AND, right? Which mine doesn't, but this one is probably more understandable, and in the end it's probably built the way it is built, because this way it is more powerful and can determine these 3 at once. So here we are, once more advertising for Geeks for Geeks. And yes, this is what I wanted to tell you about this level as well, and just in general. You would just have to sometimes, like, you wouldn't know that this is a comparator, right? And I guess let me look at the website again. It is not well, I guess it's a partial comparator, right? Not a complete comparator. Yeah, you would have to figure these things out, which is, I don't know, I think it can be fun. Here we are. This is another thing I wanted to tell you about this level. And now it's goodbye.